So we're continuing with our practice of law signs. And so here are the steps we're going to use to solve law sign problems. First, always draw and label diagram, set up your law signs proportion, and then of course solve the missing side or angle. So the idea in this case is going to, do what we normally do as with our problems. But again, the proportion is important, but draw the diagram because it really kind of tells you what the matching numbers are. It's very easy to misplace the numbers or put them in the wrong place and therefore get the wrong equation. So let's practice a couple of few problems in this case. So I'll begin with the first problem, and here we see in triangle ABC, a equals 12, sine of a equals 1/3, and the sine of c equals 1/4. They want to find c. And so let us now find, in this case, we'll set up our diagram, so we're going to figure out how to set up proportion. I mean, some of you guys are like, oh, I know how to do this. No, that's okay. But I always recommend drawing a diagram. Okay, so here we go. So let's make this angle A and make this angle B, and here's angle C. And we know that the side opposite of angle A is lowercase a, which so that we're told is 12. And the side opposite of angle C is this lowercase c, and that's our unknown value. So since we're only dealing with, in this case, angle A and the side opposite, angle C, the side opposite, we're not going to deal with angle B. So we're going to set up our equation. Our proportion in this case, the sine of A over A equals the sine of C over C. Now, here, they don't give you angle measures, they actually give you values to work with. And so let's set up our values now. We have, in this case, the sine of A is a 1/3. So I'll put this in a parenthesis, 1/3, over 12 is equal to the sine of C, which is 1/4, over C. And so here we're going to now cross multiply. And so we got 1/3 times C is equal to 1/4 times 12, which now 1/4 times 12 is 3. So we're going to continue with this, and we're going to get 1/3 times C is equal to 3. Now to find the measure C, we just multiply both sides by 3. 3 here, 3 here, and our value for the side C is going to be 9. So there you go. All right, it's pretty straightforward, hopefully. All right, I'm gonna make this a full page to get the whole thing in there so you guys can see. All right, so we see in this case, just set up your diagram. You're going to write your proportion. Make sure you fill in the proportion correctly, okay? And then, of course, solve for the equation. Okay, our next problem is going to be in triangle DAT. Now here we have angle measures, okay? So, and I'm going to try to draw this a little bit more towards what to scale-ish, if you will, what best way I can draw with my finger. So here we have our triangle DAT. Angle A is 105. So 105 is an obtuse angle, all right? So, and then, so I'll make this angle A. And then angle D is 27 degrees, and this must be angle T. All right, so let's kind of label diagrams. I wonder if I can just make this a little bit bigger. I wonder if we can do that though. So let's see, make this bigger. Okay, there it goes. Okay, all right, great. So let's kind of fill in information. So we know angle A is 105 degrees, 105 degrees, and then angle D is 27 degrees, and we're trying to find we want to find angle, we want to find D, so that's here, here's D, and we know T is opposite of angle T is 21 degrees. All right, but wait a minute though. We need to measure angle T, because the way this works out is that law of sines needs a combination of the angle and knowing the side opposite. Well, we're looking for this opposite, but we need the angle here for angle T. We can figure this out. You say, well, how? Well, we know that angle A is 105, angle D is 21, the sum of which is going to be 126. Therefore, the measure of angle T must equal to 180 minus 126. that would give us a value of 54 degrees. 54 degrees. Okay? All right. So we'll put 54 here. Now, we now know in this case we'll be using angle T as well as angle D. So our proportion will be the sine of T over T equals the sine of D over D. Okay, and now we'll fill in our information. All right, so here the sine of 27 degrees, so actually T is sine 54 degrees, sorry, sine of 54 degrees, because that's angle T, over the measure T, which is 21, is equal to the sine of angle D, which in this case is 27, over the unknown value of D. Okay, so now what we're going to do is we're going to cross multiply, all right? And so we cross multiply, we should get, in this case, what's up a little bit? We'll get D times the sine of 54 equals 21 times the sine of 27 degrees. Okay, and then we'll divide both sides by sine of 54. Remember in this case that the sine of 54 is a real number, and we can divide and multiply in the same exact way we normally do. Always remember when you're using angles, make sure you're in degree mode because that is the mode we're using here. So you're just going to do, in this case, for our problem here, 21 times the sine of 27, and divide that by the sine of 54. Sorry, my handwriting is terrible. It looks like 34. It should be 54. So I'm going to type in my calculator, 21, the sine of 27, divided by the sine of 54. Now, like always, make sure that you are in the correct mode, I said. Okay, make sure in degree mode. The default for calculators is going to be radian mode. And we'll talk about radians later on, but for now, we're going to get, in this case, the nearest integer. We find D is equal to, we have 11.7844425, blah, blah, blah. So nearest integer, D is equal to 12. Okay? All right, so